Have you ever noticed that today's AI, as brilliant as it is, feels kind of trapped? It can write you a masterpiece of an essay, but ask it to check the weather and it's stumped. Well, we're going to talk about how AI is finally breaking out of that digital box to become a real actor in the world, and what that means for, well, for all of us.
Okay, let's just jump right in. The core problem has always been this. The most powerful AI models are like these incredible brains just sitting in a jar. And this slide shows you exactly what I'm talking about. On the one hand, yeah, it can do amazing things with the data it was trained on. Write a poem, solve a math problem. But on the other hand, simple, real-world stuff, nope. Can't book a flight, can't access any new data. It's completely cut off.
So, here's the plan for this explainer. We're going to start inside that walled garden. Then we'll talk about how we can actually unlock the real world for it. We'll look at the universal connector that's making all this possible. And then we'll get into the good stuff, the promise, the peril, the new risks, and finally, how we can actually tame these powerful new AI agents.
All right, section 1, the AI's walled garden. Let's really dig into this whole brain in a jar idea. I mean, think about it. Without any way to connect to the outside world, an AI can't see, it can't act, and it definitely can't influence its environment in any real way.
And this quote from Google Research, I mean, it just hits the nail on the head. No matter how smart a model seems, without what they call external functions, it's really just a very fancy pattern prediction engine. It's fundamentally cut off from what's happening right now and has no ability to, actually do anything in our world.
So, how do we fix this? Let's move on to the solution, unlocking the real world. How do we give this powerful brain the eyes, the hands, and the voice it needs to finally step outside of its digital prison?
The answer is something we call tools. And really, the best way to think about them is like apps for an AI. As you can see here, a tool is basically a program that gives the AI eyes and hands to interact with the world. They pretty much fall into two camps: tools to know things, like fetching the latest stock price, and tools to do things, like booking that flight we talked about.
And here's a super simple example. You ask, what's the weather? The AI agent doesn't just know, it has to think. It has to come up with a plan. So first, it calls a get location tool, then it takes that location and feeds it into a get weather tool. It might even call a convert temperature tool before it finally gives you the answer. It's this whole chain of actions, all powered by different tools.
Okay, but this creates a brand new headache. If you've got dozens of AI models and thousands of tools, you end up with this tangled, chaotic mess of custom integrations. Developers call it the N by M problem. It's a nightmare. So how do you solve that?
Well, the solution is a standardized protocol. It's called the Model Context Protocol, or MCP. Honestly, you can just think of it as a universal adapter for the entire AI ecosystem. It creates one standard way for any AI app to talk to any external tool. It just makes everything plug and play.
So, how does MCP actually pull this off? Well, it starts with what's called the host. The host is your main application, the AI agent you're actually talking to. It's the conductor of the orchestra, managing the whole experience and deciding which tools to use. Now, living inside that host is a client, and its job is super specific. It handles the actual phone call to the outside world. It's the piece that reaches out and manages the connection to get the tools it needs.
And where does that client connect? To a server. The server is where the tools actually live. It basically puts up a sign that says, hey, I can get the weather, or I can book a flight. So any client can discover and use what it has to offer. This whole three-part system keeps everything neat and tidy.
So MCP creates this amazing, flexible world of tools. But, and this is a big but, this new power is absolutely a double-edged sword. It comes with some really significant trade-offs and some serious challenges.
I mean, the promise is huge. With a standard like MCP, development just takes off. Suddenly you have this marketplace of reusable tools, and agents can become way more autonomous. They can discover and string together the tools they need on the fly to solve really complex problems. It's a game changer.
But here's the peril. For an AI to use a tool, it has to read its instruction manual, right? Well, if you stuff too many of those manuals into a short-term memory, its context window, it can actually start to get confused and its reasoning gets worse. And on top of that, the protocol itself has these big, gaping holes when it comes to enterprise security. It's just not built for it out of the box.
And those enterprise gaps? Well, they bring us to our next section, a new world of risk. They basically open a Pandora's box of complex security threats that are totally unique to this new agentic world. And just look at this chart. It shows what people are actually using MCP for. And it's pretty obvious. Tools are supported by 99% of public clients. That giant slice tells us exactly where the fire is. It tells us that securing these tools has to be priority number one.
So let me show you a really clever attack called tool shadowing. On the left, you've got a secure, legitimate tool with a super specific description. On the right, you have a malicious one with a really broad, tempting description. An AI, just trying to be helpful, might easily pick the malicious one. And just like that, sensitive data gets sent straight to an attacker.
And that leads to an even more dangerous classic security problem known as the confused deputy. It's a great name because it's exactly what it sounds like. In this attack, the AI itself is the deputy. It's a program with legitimate power, but it gets tricked by a bad actor into misusing that power for them.
And here's exactly how that can work. An attacker gives the AI a prompt that looks totally innocent. It asks the AI to do a couple of legitimate things. First, find a sensitive file, and second, create a public backup of it. Each step on its own seems fine.
The AI, our confused deputy, has no idea the user shouldn't have access to that file. It just follows instructions, passing the commands along to the highly privileged MCP server. The server executes them, and boom. The attacker has completely bypassed security without ever having to hack the system directly. They just trip the AI into doing it for them.
So, this is the critical question, right? How do we use all of this incredible power safely? How do we build systems that are not just smart and capable, but also trustworthy and secure from the ground up? Well, the answer is all about defense in depth, building layers of security. It starts with a gatekeeper, a strict allow list of approved tools. For anything high risk, you absolutely need a human in the loop to give that final okay. Every tool should have just enough power to do its one job and nothing more. And maybe most importantly, you have to clean and sanitize every piece of data going in and out of the system.
You know, in the end, protocols like MCP are incredible. They give us the plumbing to connect AI to the world, and that unlocks immense power. But the technology itself isn't the final answer. The responsibility for building a secure, reliable, and trustworthy framework around it, well, that rests with us, the builders. And that's the real challenge ahead.